Hello, welcome. This is a demonstration that was presented for Consensus 2018 of Hyperledger Fabric in a real-world use case prepared by Alturos. This is a presentation of a decentralized peer-to-peer security transfer solution that was implemented on Fabric. So we will step through the solution design, how Hyperledger Fabric was utilized, and some of the background of the use case for this project. So we'll step through use case, the architecture, and we'll give a brief demonstration of the end solution and go from there. So jumping into the use case, specifically involving intermediaries in peer-to-peer securities transfer on blockchain. So current state, securities settlement processes, kind of a well-known use case for blockchain at this point, but in the traditional implementation can be a very slow, somewhat tedious process for banking institutions. A lot of processes done manually in terms of the verification of both sides of a transaction and the verification steps that are typically involved, and will in most cases involve at least three active parties in the settlement process, being the depository, the issuer of the security, and the investor. So the solution here in this case mirrored that network or that group of participants. So you had the depository institution that was helping to administer the network and set it up, process what were ultimately the blockchain orders, creating the security that would be represented on the blockchain, or the asset represented on the blockchain. And lastly, perhaps most importantly, maintaining the banking records of the other parties involved. So we'll step through just the network architecture, and what this particularly highlights is Hyperledger Fabric's functionality of channels and the ability to, within a blockchain network, on a blockchain ledger, still control or customize what individual participants are able to see within that network. So quick diagram, just kind of some of the systems level or the technology stack with Fabric, a number of different pieces, but representing here just the individual components that fall underneath each of these three participants. So you have a two-peer network with the third participant being the depository. So in terms of channels, you end up with a common channel, kind of a broadcast channel, representing information or activity that is that can be seen by all participants. This is generally used for querying what assets have been created and what assets are available within the full network. There's the depository channel, which is essentially a depository's own maintenance of the balances of the participants on the chain, and the logging of all asset transfers and the corresponding payment structures. Then importantly, two bilateral channels, and this was kind of the main ask or request of the use case. The participants wanted to be able to engage in peer-to-peer transactions, engage in a peer-to-peer asset transfer, but the balance information, essentially each participant's private banking information as to essentially totals or items of their balance sheet and account balances, they did not want to be visible to the other participant. So the NSD essentially was kind of the clearinghouse and settlement processor for those balances. So each participant could, on their respective channel, view their balances, but not have that information be visible to the other participant. And then ultimately for transacting, there was a three-party channel for both the peers and the NSD institution. So, and essentially the distinction between this and a common channel is, if you can picture ultimately, and in the future, is the intention of adding more parties and having this be a kind of widespread network with NSD in the center. Each transacting trio would be represented by this sort of channel, and then all participants, so it could be 5, 6, or more, would collectively be on the common channel. So in terms of chain code, the smart contract logic employed on the network, one of the smart contracts was book. This was deployed on that depository channel and was essentially in charge of maintaining the records of the various quantities held by each member, and then was updated upon receiving events for securities transfer. Instruction is essentially the smart contract logic that executed the securities transfer. So this would be on the 3 participant channel between the 2 peers and NSD, and would record and log the transfer quantities of all the securities, the security issuances executed on the network. Position is essentially the smart contract executing that banking account type of information. So each peer with NSD, when they wanted to query off the ledger to see and update their holdings, their positions individually, this was executed on the position contract. The security finally being on the common channel, which is really just a running ledger of all the assets that had been created on the network. So the ultimate solution allowed for really creation of any blockchain representing asset or any asset that was to be recorded on the blockchain. So in this case, it was a bond issuance, but allowing for creation of other assets. So the list of available assets being on the common security smart contract. In terms of the technology stack, this was utilizing again Hyperledger Fabric. So Alturos designed and implemented a client-facing web interface, and also at the time, sort of the version of Hyperledger Fabric, the REST API was somewhat in development. So there was some work that Alturos did also to develop sort of a customized REST interface for the web facing UI to interact with. So that will jump over quickly to the demonstration of the ultimate solution. So you see here we have 3 windows open. This would be after logging in to each organization's individual interface. So they all have unique access. So this being the NSD's window, you see here, in contrast to the other peers, some of the unique functionality or accessibility for the NSD is to, as we see here, create new securities. So these are the blockchain representation here of the bond issuance or the bond asset to be transferred. Also allowing for the NSD, again, as that account holding entity within the network to establish what the actual cash positions of the other participants are. So this, again, being the centralized view that is available to NSD. And then we'll see in a moment here that each of the other participants can see transactions or transaction history for the assets, but their balance positions, the sensitive cash position information, you'll see here that they see a unique slice of that data particular to their organization, and they do not see the other organization's holdings. So two primary issuance or settlement mechanisms that were employed in the solution, very common in the financial settlement space. So free of payment and delivery versus payment mechanisms. And the logic employed is a fairly simple matching logic. So essentially both parties would initiate the same transaction command on that instruction chain code. One would be initiating the transfer, and one would be initiating the receipt. And the logic employed required that all the metadata that you can see here, so all the account specifics, that had to match exactly for the transaction to be approved. So that was sort of the control mechanism used here. So required specifying the security, and then details here you can see reference is more or less just another layer of unique identifiers to sort of a future proofing of the concept to allow for a unique identifier here just kind of being a generic reference number employed. And so we see that the status, it's briefly goes to matched as the chain code is processing those two sides of the transaction, someone initiating a transfer and another party initiating a receipt command to the chain code. And then as soon as it's matched, it's translated to status executed. And so we'll still see here each participant sees the transaction or their side of the transaction that they have initiated. And then you see on NSD, there is the dual view of both of those chain code invocations that were used. So here we'll run briefly through the similar transaction. So that was free of payment. And then the second demonstration here being delivery versus payment. So just requires also including some of that cash balance account information also needs to match in the event that it's delivery versus payment. And it is in that sense that this we feel is an important use case and one at least for the immediate future. Now permanently will continue to be frequently required in the sense that if parties are transacting with traditional fiat currencies but want the transaction history, the ledger, to be on blockchain, it's what we saw here, and will frequently be required that there continues to be somewhat of a traditional banking intermediary involved in some sense for the handling of those fiat transfers. So kind of a hybrid solution that was required in this instance. So we see here the status, if you saw in the previous screen, when one party has initiated, will sit in that initiated state, waiting for the other counterparty, or waiting for essentially a matching record to be posted to the blockchain through the instruction smart contract. So here's some of that additional detail required for delivery versus payment, matching that cash transfer that needs to occur. Again, also needs to be 100% matched for the instruction chain code to validate the transaction request and process it. So we see matched there briefly as the transaction is processing, and then moves to executed. And each side seeing the transaction event in the ledger, and now here NSD, we see the balances have updated and revised, the quantity transfer that's occurred, and then again that both sides of the transaction logged within the NSD ledgers through its blockchain code. And each side again sees their updated positions in terms of security and their cash position, but does not see the other party's side, which is one of the main requirements. So again, it's providing parties all the access to the security transaction events. Everything that occurs there is visible to them, but the resulting positions and balances of each party is continued to be private. So thanks very much for watching. We appreciate you taking the time. Hopefully this was informative. And if you have any further questions, please feel free to reach out to us. Thanks very much.